Hi, Algebra 1. We're going to move on to section 212. So you need your activity page. You received this in class. Again, if not, make sure you have a blank piece of paper and you are answering all the questions and writing in all of those questions. So what we're going to be looking at today is we're going to continue on our exploration of linear. And so again, we're in chapter 2, which is all about lines. And so today the question that I want you to keep in the back of your mind is, how can I measure steepness? How steep is a line? So with the patterns, the tile patterns that you watched earlier, you looked at what is the growth, meaning how are you adding tiles each time? And then what was figure 0? Meaning what was the starting value? So we're going to expand on that idea of growth and starting point. And so let's just dive right into question 211. That's going to be the first question on your notes. And it says, write an equation for this. So when we write an equation, remember what we're looking for is we're looking for that pattern. And I'm going to be using red here. So we are looking for a pattern. I tried to draw on those arrows for you, not maybe the clearest, but that's what those are. So I want you to think about the pattern. Look at 2, 7, 12, 17, 22. What are you adding each time? Yeah. Well, I hope we all see that we're adding 5 each time. Okay, so we're adding 5, we're adding 5, we're adding 5. So that means figure 0 had 2 tiles, figure 1 had 7. All I did was add that 5 in. Now, this is going to come here later, but I want you to also be checking that pattern in the X. Right now, it's not too big of a deal because what is the pattern in the X? Well, I went from 0, 1, 2, 3, 4. I'm just adding 1. We've been adding 1 in that pattern of the X for a long time, but that might change here in a little bit. So just keep in mind the pattern in the Y, first thing you check, and then we're going to look at the pattern in the X. Okay, but we're not done because remember, we have to figure out that's our growth rate. Our growth is we're always adding 5. But the second thing that we looked at was what was in figure 0, meaning what's our starting point? Well, that's our starting point. So now I have all of those necessary ingredients to write the equation of my line. So I'm going to come down here and I'm going to write y equals, remember our growth rate was the number next to x, so 5x, and my starting point was a positive 2. And so that's my equation, y equals 5x plus 2. Now here is something that I always like to check. Pick a number, okay, or pick a point. I'm going to pick this point right here, 422. Now that's not the beginning point, that's just a point I picked, and I'm going to try to put that into my formula to see what happens. So when I pick y equals 5, now I picked figure 4, so I'm going to plug in 4 plus 22. If that doesn't give me 22, then my equation is wrong. My 5x plus 2 is wrong. But 5 times 4 is 20. 20 plus 2, check. Good. That is my output, and that's what my table says. So that's your equation. Okay. So this next question asks, does it appear to be a function? So remember functions, those are the soda machine examples. Did we have any repeating buttons? Meaning, did we have 2 repeating inputs? And in our table, we didn't. We had a 0, 1, 2, 3, and 4 for our input. And so we only, for every input, we had 1 and only 1 output, which means that yes, it is a function. So that means we now need to write this equation in function notation. Now don't be scared about this. Remember, f of x is our fancy y. So it's still 5x plus 2, but instead of saying y, okay, we just write 5x plus 2. If you haven't already, make sure questions 211 and 212 are filled in on your notes. If you need to pause the video now. And finished questions 211 and 212. All right, so let's see if we can put all of this together. Remember, sometimes we'll give you a table, sometimes we'll give you a graph, sometimes we'll give you a story problem, but you have to be able to find growth, and you have to be able to find the starting point no matter what we give you. So let's take a look at this first one. It's in graph formation, so now we have to think about, all right, I'm looking for the pattern in the Y. Now, I drew the arrow on your graph papers differently, just to give you an idea that you can draw it differently. But notice I have a bunch of points here. Okay, I've got points there, and I've got points here, and I've got points here. But also notice my scale here. Notice we've got ones, and so we're going over one. That means you kind of have to think about that scale. So remember, the change in Y is the direction of, that's vertical. Y is vertical. So if I start at this point, I'm going to erase that middle point. If I start at this red point and I go to that red point, how far up did I go? Well, I started at 3 and I went up to 7. So that means I went up 4. Okay, now I'm going to check my X direction. So if I started at 0 and I went over 1. Whoa. Okay, so I went over 1. So that means my pattern is growing by 4 tiles. So for every one figure, I'm adding 4. Okay, so it says how many tiles are in figure 0. So here we go. We're looking for, and I'm going to try to keep these colors consistent, just like in the tables, yellow. So I'm looking at when x equals 0. Well, here's x equal to 2. There's x equal to 1. That's x equal to 0. So where is it on the graph? Oh, there it is. So my point, okay, and I'm going to write it as a point here so you guys can see this, but my figure 0 has 3 tiles in it. Get used to writing it as that coordinate point. When x is 0, y is what? All right, now it says write the equation. So my equation is y equals, my growth goes next to my x, so 4 times x, now plus my starting point, okay, plus 3. Now this one says, does the graph represent a function? And remember that challenge question? Are all lines functions? And we found out every single line is a function except for the vertical line. So this is not a vertical line. So yes, it is a function. All right, pause the video here, and you need to answer questions B and C on your own. We will check parts B and C in class. Okay, so try this one on your own and see how you do when we get back to class. All right, now that you've had a chance to finish question 213, okay, we're now ready to start on that second page in your notes. And the question 214 should in your notes look exactly like this. So this one is asking the same questions. Notice the questions don't change. What is the growth rate? Where's the starting point? What's the growth rate? What's the starting point? Same questions, always a different scenario or line. So let's take a look at this guy. So again, X is the figure number. So figure 1, figure 2, figure 3. Y is the number of tiles. So notice we have no numbers down here, which is okay. That's not a big deal. But what we do know is that our pattern in the Y direction is 27. Okay, so that means I have 27 tiles. But here's where I want you to think about this. Look at my triangle here that I just drew. Normally, we would have 1 there, but this time we don't. This time we have a 3. So that means we've moved 27 tiles, but this time it's not for 1 figure, it's every 3 figures. So I'm going to write that with some units. So this represents 27 tiles in 3 figures, which is fine. That's a fine way to write that because you have 27 divided by 3. So, and for every, we'll say figure number, 3 figure numbers. Okay, so if you move 3 figures over, so you started at 1 and then you went 2, 3, 4, that would have added 27 tiles. But what's wrong with that? Well, is it possible to know how many tiles are added every figure number? Meaning, I want to know what happens at figure 4 and then what happened at figure 5. Can I figure out what happens for every one figure? Sure. Well, what's 27 divided by 3? Somebody said it out there. Remember, talk to me even though you're not, I can't hear you. It's okay to talk. So 27 divided by 3 gives us 9 tiles for every one figure number. And notice it's a fraction. All I did was reduce. So it says, explain how you found your answer. Reduce a fraction. That's a great way to explain your answer. You could be saying I got it into a unit fraction, meaning the denominator is 1. For every one figure number I move over, I add 9 tiles. So what I really want you guys to understand about this is right here. You don't always have to divide by 1 there. You might not always be going to the right one jump. Sometimes we might take a jump of 3, like in this example. Sometimes it might be a jump of 9. But in the past, our figure numbers only went up by 1. That's going to change, and we're going to be able to take figure numbers like I jumped 3 instead of 1. Okay, pause the video if you need to and fill in question 214. All right, now question 215 is where we get into the real algebra notation. Remember when we started with what's f of x? You guys are learning more and more algebraic notation. And so what we want to do is we want to formalize what slope is. Slope measures how steep a line is. And to measure the steepness, what you need to do is you need to figure out what is your change in y. And that little triangle, which I've written out for you, that triangle in mathematics means change. So I'm going to put in 2 points here. I'm going to put in those 2 points. And I will always put my change in y in red. So what I do is I come up here in red and I go, I was started here at 3 and I went up to 5. And then my change in x, or how far did I go horizontally, will always be in blue. So how far over did I move? Okay, well, let's see here. Let me erase that. Let me get my spotlight here. So here was, I moved over 1, 2, 3, 4. So my change in y, again, is red. So I moved up 1, 2. So I moved up 2, and then I moved over 4. Okay, so my slope is going to always be red over blue, or the change in y divided by the change in x. Now, if you're going to be the student who flips this and says it's 4 over 2, I will always have you color code your slope, meaning I'll always have you put the change in y in red and the change in x in blue. So that way you always know it's going to be red over blue. So my slope, okay, and I'm going to draw this out and I'll do this here. So I'm going to put this here. So my slope for this guy is going to be my change in y is red. And again, I represent my change in y as red and my change in x as blue. So I have 2 over 4. Now, algebra 1, very important. If you can reduce that, you should. So that's what question C is asking. Can you draw a smaller slope triangle for this line that has a vertical distance of 1? Sure you can. Your slope triangles can be lots of different heights. Now notice, this one is going to be, it's going to have the x first, then the y. It's okay. But notice I have a change of y. This little guy is a change of y of 1. So what does that mean for my change in x? Well, let's find out. Notice it doesn't matter how you draw your slope triangle. Like this one I drew, I went up and to the right. This one I drew it from the right and then up. It's okay. It doesn't matter. You're still going to get your change in x of 2. Well, let's come back over here. Look at our slope. It was 2 over 4. And what is 2/4 reduced to? You said it. You got it. It's 1/2. Okay? So you can, when you write your equations, you're going to always need to write it in the slope is this reduced, the most reduced. So we're going to want 1. All right. So we're going to look at this slope now to write the equation of a line. Now remember what this means in figure numbers. So that means for every 4 figure numbers, okay, I am going to be adding 2 tiles. This one means for every 2 figure numbers, I'm adding 1 tile. Now we could go even further and say it's 0.5 over 1. So you're adding a half of a tile for every time you move over. And we're going to write it like this. So y equals my slope or my growth pattern. Remember, your slope represents your growth. How steep is that graph? And that's going to be 1/2. Remember, it's the number in front of the x, so it's 1/2 x. Ooh, but where does this graph start? You got to find that starting point, and it's where it's the y when x equals 0. So there's x equals 0. I go up, and it's 2. So my starting point, or my figure 0, is 2. So the equation of this line is y equals 1/2 x plus 2. Okay, we're going to get really used to these change in y and change of x. That's a new way of looking at something. But just remember that the change in y is just how do you change vertically. The change in x is how do you compare horizontally. So it's always going to be a fraction. Your slope or your growth rate is always a fraction. Okay. Now we're going to do these next problems in class together. But I want you to try question 216. So they gave you they gave you 2 slope triangles, and you need to put this in. So on this guy, here's your slope. Okay, I went up this far, and on this guy, I went up this far, and then on this triangle, I went over 4. And on this one, I went over 2, okay? So I want you to think about what's the change in y divided by the change in x for the big triangle A, and then write out what's the change in y divided by the change in x for the little triangle B, and then give us a sentence. What do you notice? What do you notice about those 2 slopes and this one line? Okay, make sure that you write your answer in, and we're going to check that one in class. All right, the last question, again, is a challenge question. I want you guys, I've drawn in those 2 lines for you. The first one, it represents a change of y of 0. The second one represents a change of x of 0. And I want you to think about the slope. So, challenge question for all of you. And then we will talk about this one in class. So what is the slope of this line? What is the change in y? And m is slope, guys. I just put m, but that m stands for slope. And I will erase that right now. You're going to see that, but that's kind of confusing right now. I don't want to throw all of that at you. So let's do slope equals the change in y divided by the change in x. I want you to find the slope of this line. And then we're going to talk about in class. Okay, for this one, I want you to find the slope of this vertical line. Okay, again, slope is what is the change in y divided by the change in x. Now in yellow here, I have what would the tables look like? Put some points on these lines and make yourself a table and see what the tables look like. All right, some challenge problems. Make sure you finish the first two. So question 213, you need to finish. And then question 216 and 217, you need to finish for your next in-class day. We'll be checking these notes and going over just those few. Thank you for watching Algebra 1. We will see you in class.